Hello, guys, and welcome again to this stream. I'm going to just double check, make sure everything's up and running. I can see my stream seems to be connected. And I think that's about it. We can get the ball rolling tonight. So, hello and welcome everyone. My name is Will, and this is C-Sharp Walkthroughs. Excuse me. Tonight, what I want to do is kind of do this, again, as I always say, a chilled live stream. I was asked in the comment section in one of my previous live streams regarding LAN network connectivity. And I was asked by a user to just kind of go into more details into how you can connect two endpoints using LAN, primarily using the sockets namespace provided by .NET, and I'm using C Sharp. And I thought it'd be a really good idea to kind of explore this topic because in the back end, off screen, I have been working on some more of the LAN functionality, and I made a little bit of progress. And I think it would be kind of neat to sort of continue this series and sort of look at how we may be able to apply this technology within a more concrete context, such as a game, to hopefully, if we can get through the steps, do what we need to do, sort of like create this very simple LAN connectivity in that you can play a little multiplayer session in a very simple UWP game. So without much further ado, let's kind of get through things. Let's get this started. I'm going to see if I can. It's probably going to be a little bit over an hour. I do like to keep these streams to like an hour, but I feel like we have quite a few things to get through. And when it comes to LAN networking and sockets programming, it can be quite an involved process. So let's just kind of see where we go with this. First things first, what I want to do, if you guys recall my other video, you might recall this project. Now I know there's a lot of things on the screen. We have two Visual Studios up. We have this kind of test bench, I'm calling it, on the left hand side. We have a tic-tac-toe game, and just some notes here so we know where we're going, just to keep things a bit organized. So what I'll do first, I'll show you the test bench. And in my test bench application, assuming everything kind of goes right in terms of the code base, it actually provides very, very simple client-server functionality. And the way I've done this, because I'm targeting my own local area network, I can use this test bench on its own to kind of ping itself, as it were, or to send a packet to itself. So what I'll do, I'll quickly demonstrate this. So we have listen for requests. So I'm initializing the server effectively. And we'll go through the code in a minute. It's just kind of loading. There we go. It's kind of done its thing. Let's request a connection to the server. Hopefully it works. And as you can see on the screen, there's a bit of an update. It actually should say hello world, but it looks like the packet that contains the string is for some reason kind of trimming or cropping the HEL part. It should say hello world, but you can kind of get where I was going with that. And it's a bit, should I say, it's not very obvious just by looking at this example, but what's actually happening, I didn't just update a text field with a variable per se. What I actually did was initialize a socket server. So once I press this button, and I'll go through the code base, I'm just going to kind of overview things so we can kind of get an idea. This, as soon as I clicked this, it was listening for requests from any incoming client requests. And then once I clicked this button, the client mode of this test bench actually requested authentication, as it were, with the server component. Once that was initialized or initiated, I invoked a packet handler. If I just close this, I invoked a packet handler, which hopefully I should see the solution explorer. So this is my packet handler. I basically loaded the packet. Over here, I'm going to go through things step by step to kind of refresh our memories and to kind of just show you guys how you can kind of get started if you're, want to get started on sockets programming. So I'll go from the beginning and I'll go back. So this is just an overview. I invoke the packet handler, and then I basically, looking at the front end, once the packet is received, there's actually, I'm trying to find where I am now. That's the LAN mode. So basically, it might be actually worth me mentioning, excuse me, my implementation is actually if I'm not mistaken, it's a UWP, Universal Windows library project type. So I implemented the LAN mode implementation as a UWP library. Now I'm thinking, ideally, I want to basically, what I could do for the component, so on this right hand side where I have the tic-tac-toe, I'm going to demonstrate in a minute, I could just export this library as a DLL and just expose the needed functionality. But what I'm going to do, I'm actually going to just recreate the classes in a namespace in this solution, just so I can have a more direct, should I say, debugging experience, as it were. And then, of course, when things are more, should I say, out of the gate in terms of the functionality, then I could kind of look at importing DLLs and kind of like doing things that way. So where are we? Let me just zoom in to the screen a little bit. Where was I? Yeah, so I was going to show you the UWP front. If I go to, so I have two projects in this solution. I have the library over here, which I'm highlighting, LAN mode, which is a universal Windows library. And then I have this sockets test app, which is actually a UWP front. So here on the UWP front, we have the main page.xaml. We're going to go to the main page.xaml.cs file. And what I'm going to do, just to kind of run you through what's actually going on. I might have to zoom out just a little bit so it's easy for me to see. I've invoked this kind of polling clock. Now, what this polling clock does, if I'm not mistaken, it's just a dispatcher timer. So I'm going to go to its definitions just to double check, make sure I'm doing that right. Polling clock. So if you, let's say, let me do this step by step and just kind of break it down so that we can all follow what's going on. If you want to do this, kind of make your own sort of LAN implementation, I would recommend implement some kind of dispatcher timer. In this case, it has a kind of polling functionality in that I am checking the state of the network. So again, I'm not going to go through every single thing. I'm not going to kind of explain what a dispatcher timer is and what certain classes do per se. I kind of want to just overview things to kind of fit it within this short space of time we have. It's only going to be like about an hour or hour and a half or something. Hopefully, if we can get through the majority of stuff. But what I did, I have this dispatcher timer, set its properties, so its interval, it checks, I think that's every second I set it to check. And I basically hooked a method to the tick event. So every time that this dispatcher timer ticks, I'm invoking this method, which is polling clock underscore tick. And what I'm doing, the packet handler is actually, I think it's statically, no, it's not, is it a static class? No, it's not. But that's very fascinating. So it's not a static class, but I do have static members inside of this class, which is fair game because, sorry, I do live in a communal place, so I was a little distracted. But anyway, what you can do is have static members in a non-static context, if that's the right sort of terminology. As soon as I saw this, I just thought I am, accessing a static class, but I'm not. But I'm basically still, nevertheless, because it's a static member, I'm accessing, better said, this member as such. I'm calling the class itself using the .accessor packet buffer, which this packet buffer is, if I'm not mistaken, it is, because I did write this code base some time ago, but just by looking at the way I've written the code, once I have authenticated the connection, this packet buffer actually contains the hello world string, if I'm not mistaken. And so what this evaluation does, as soon as the front end, so when you saw the test bench, the UWP front loaded up and that you saw like the button controls and stuff, this clock is already ticking. And what it's doing is doing a check. So it's checking if this packet buffer is empty, just do nothing. But if the packet buffer is populated, and when you think about it, I'm actually checking an inequality. So this packet buffer, which is by default string.empty if I'm not mistaken, this is also string.empty effectively because I've got a declaration and I don't know if I'm instantiating a value, it doesn't seem like it. But anyway, this is empty at first, so this actually evaluates for false. As soon as this, I authenticate a connection, and then I populate the packet with the string to send over the network to the server component. This actually evaluates for true because this inequality holds for true. This remains string.empty, but this is the hello world string, as it were. And what I actually opted to do here is that this packet buffer is like a buffer for the buffer. So I update the value of this member with the information that I'm sending over the network. And so this then holds for false once again. Because when you think about it, it's an inequality, but they're going to be the same. And this will only update if the underlying packet data is changed. So what this means is that we have a little system whereby we can basically send different packets, different data within a packet, and we can then know to update the program because we're checking for this inequality here. And then I'm just doing a very simple update to the text property of my XAML. So I have packet information text block, which I then update the text property to have the content of the packet buffer, which is where you saw the kind of hello world with the trimmed hello bit. I think that's just because I'm using like maybe the wrong indexing or something. I'm not too sure why the hello is being trimmed. So since we've gone through that, I think what I'll do, I will quickly demonstrate this tic-tac-toe. Then I'll dive into how this is working. So what I'm going to do is just to show you the context at which I would like to eventually get this, what seems to be the line component at a bare bones level is working. The context I want to implement that for, which is like a simple UWP game. I'm going to demonstrate that now. And then I'm going to show you the workflow for the actual LAN component of my test bench, which if I collapse the UWP front and I just expose the packet handler, or rather the library, the LAN library, I have here packet client and server namespaces. So we're going to, I guess we could start with the server, work our way through to the client, and then we'll look at the packet. So let's just boot this up. This is the tic-tac-toe game, which you may have seen in one of my other live streams. I built this tic-tac-toe game in one of my live streams in one session. And since it's a very simple kind of implementation of tic-tac-toe, it might make a good kind of experimental ground for this kind of LAN application. Again, not everything might be gone through in this one live stream. This is actually part 2 technically, I suppose, as I did the part 1 some weeks ago. So I'm just going to boot up my simple tic-tac-toe game. Alright, so what we have here is a simple UWP front. I have here, this is a Win2D application in that I'm using Win2D to power the graphics as opposed to just raw XAML. And I'm using the number pad on my keyboard. So if you visualize, or if you have a number pad on your keyboard, you have 1 to 9 in a particular configuration, and it just pertains to the positions on the tiles. So you're playing tic-tac-toe. I'm almost playing by myself, so I'm going to press the number 1, bottom left. Now for, as it were, player 2, I'm going to press 9. Let's make sure that works. My button might be a bit stuck. There we go. And then I'm going to try and win for 0 since I was the first one. Put that there. I'll put 1 on the top left. And then I'll finally end the game like that, which kind of resets the visual. It's just the idea behind it. So what I want to eventually do is just to kind of verify that we can communicate this game with our LAN library, which can then speak to another UWP game session, as it were. So we're making one session with 2 UWP games, both communicating to play tic-tac-toe. What I'm not going to do probably today is to have two instances of tic-tac-toe. I'm just going to use one instance of this tic-tac-toe game, I'm thinking. I'm going to interface it with the test bench so I can just kind of more clearly debug things. And then once I've, should I say, more solidly establish what's going on and things are working, then I feel more confident actually maybe hooking this up to. I have a laptop here, but it's going to be off screen, so there's no point doing it. I can have like two instances of the same game, or maybe two separate instances, whatever. But the main idea is having two sessions discrete from each other, communicating via the same network. I think I have a little agenda here somewhere. So where are we? So we've done the LAN test bench demo. Rundown of the LAN implementation. We're going to do that now. So I'm going to cross out the UWP game demo since we just did that. Going to give you guys a rundown of the implementation, and then we're going to move to actually applying, because right now this tic-tac-toe has no network application or no network implementation. In my namespaces, it's just assets, as in the graphical assets, controllers, models, and views. But here I have client packet server, so we're going to implement the network functionality with tic-tac-toe. Let's run down what's actually happening. I think that might be a good place to go now. So when I listen for requests from the server component, I'm invoking a function here. So let's see where I am. I'm looking at initialize server. There's a reference. So there's a button, client server, toggle button click. So when I press the button to listen for requests via the server component, I'm calling a function called initialize server, which is down here. And what I'm doing, I'm constructing this LAN server object. So we're going to go to this class called LAN server, which is right here. And so this has the constructor is parameterless. There's no real implementation here. But nonetheless, I just did it as such, as with most kind of general classes. I might actually want to have some initialization logic here. For example, I could automatically call initialize server in the constructor, but what I've done is to just kind of call it from the UWP front. So LAN server, if I'm not mistaken, that's actually in the namespace, in my LAN mode namespace, which what you want to do. So if you want to implement your solution via like a UWP library, you can. What I opted to do was I created a solution file called LAN mode, and then within that solution, I have a UWP app, and I also have the library itself. So there's a way you can do that with the template. I'm not gonna like go through that now because I'll have to like, start a new Visual Studio session and just kind of run it through. But just know that I have one solution with two projects, as it were, the LAN mode library and the UWP front. Both UWP in nature, in that the library is UWP and the front is UWP. And I'm referencing LAN mode here in my UWP front. And I'm also referencing LAN mode.packet, so that it just makes it easier to access members within the namespace. Okay. So what we have to do, I'm calling a function within this LAN server class. And this function is initialize server, and I have a little bit of a workflow. So what I'm doing here is I'm binding, I'm listening, and then I'm accepting. So let's see what these three steps are actually doing under the hood to kind of understand what this workflow does. Bind. So what I'm doing first is that first things first, let's kind of go through namespaces. So I'm calling systems.socket. It's saying it's unnecessary, which is fine. I would just call it there anyway. I'm probably calling it somewhere else. Yeah, there it is, sorry. So I've done it twice. So make sure you have your systems.net.sockets namespace. I also have system.net just in case. Excuse me. And in my bind function, I'm calling the IP address class. I'm basically, I don't even know, I'll be honest, I'm not sure if I'm constructing this class per se. But in any case, this is how the syntax goes. IP address get IP address is the name of the member referencing this class. And then I have this var object, so host. And then I'm assigning it a value of the DNS class, which is in the system.net namespace, get host entry. and then DNS get host name. So what this actually does, it gets the, if I'm not mistaken, the machine. I think it's the machine name of the component in question. In this case, it would be my workstation, which is just over here. Be the name of my workstation. But in this case, just by looking at this, because what you can do is, what I'm doing here is actually looking for the IP address, if I'm not mistaken. But I think you can get like the host name as well, which is right here. So the host name of the machine. But in this case, what I'm doing, I'm for each looping through the potential address list with respect to the IP addresses. Because I think you can have multiple IP addresses for one machine, depending on different contexts. And I'm doing a simple equality check. I'm evaluating the value of IP, which I'm doing like a sort of typecast here. I'm saying IP for each IP address in this list. This is a property in this DNS class, calling this functionality. I'm doing a check, and I'm basically saying, okay, if I can find the respective IP address, so on the right-hand side of this equality check, I'm calling address family and internetwork. Address for IP version 4, then I'm returning the IP address. Otherwise, it's just returning null, basically. So if we're returning this, we'll go back to where we're calling this. But I'm just looking at this now because I'm a little puzzled. Because if I'm returning this isn't really assigning to anything, is it? Let me just have a double check because I have some more stuff here. So again, quick disclaimer, a lot of the code itself is still kind of in the works, so I'm thinking through this as I'm showing it as well. So considering the fact that this for each loop, okay, that's fine. Yeah. Oh, sorry guys, I got really confused. I thought I was constructing the class. This is a local function. So sorry, because I'm so used to my local functions being void all the time. This is not a constructor of this class. I'm really sorry, my mistake. This is a local function called get IP address, and I'm making the call here. So I'm passing the return value of get IP address as an argument to the IP endpoint. And that makes a little bit more sense. Because when you call the bind function, which is accessible via the sockets, netsockets com, so sorry. Let me see what I'm doing here. Let me just quick check this definition. When you construct the sockets class here, so I've got a member declaration for the sockets class. You can access this bind function, and you need to pass the IP endpoint in question. So basically the endpoint, let's have a look what it says so that I'm not spreading more misinformation. So the IP endpoint initializes a new instance of the IP endpoints class with the specified address and port number. So with the IP address and the port number, the two actually together, they're considered the socket. You could loosely kind of consider the port number and the IP address of a particular, let's say, endpoint as a socket. So if we're getting the IP address that we need, and the IP address we're looking at, if we look at this function, is that of the machine that we are concerned with, and not the target machine. It's the actual, in this case, it is the server, I believe, because where are we? Yeah, we're in the netsocket com server. So this is listening. Remember, we're still listening for requests. We're just initializing everything on the server side. And we also pass a port number, which is actually hard-coded for now. I have a public int port number, which I'm returning this field, which is just 1920. It's a random number. It can be fairly random. I think there are some restrictions to what your port number can be, but in this case, it's 1920. Kind of just an arbitrary number. Great. So once we pass a valid IP address and port number, then this will pass. We can then pass the bind function. So let's go back to our LAN server class, which has this workflow. Once we've successfully binded our network, what we want to do is listen. So let's have a look at what's going on here. So here, listen on the socket for incoming connection requests, and it's quite simple. Just again, we have the socket, this member, which is a declaration of the sockets class, which gives us access to this listen function. And I passed it in the argument this 500, which I'm not even sure what it does. Let's see what it does, if I can find it. So the backlog there, the argument is, as it says here, the maximum length of the pending connections queue. So I think that pertains to how many kind of connections can be authenticated, I suppose. Or that can be pending to then be authenticated. Now, let's see what I'm doing here. So once this has been called, the next step is to then accept. Let's look at what's going on here. Now, the interesting thing is, I didn't experience any locking, any thread locking. And that might be because, but then I'm not too sure about this because I'm seeing an async keyword in my function for accept. So I'm calling public async void accept, and I have socket begin accept. But really, you should prefix this line with the await keyword. But it looks like I'm having some issues with that, and I don't want to really modify what seems to be working right now. But then it could be a case of the inherent, the actual. I mean, I don't know if I can actually inspect this listen function. I'm gonna see if I can go in. Yeah, so we have all this kind of stuff. So the actual listen function itself, I probably won't be able to see everything, but it might be written such that it doesn't lock the threads itself. So because that's why I can still interact with the UI without having to accept as such. So because sometimes what will happen if you're on a listening kind of loop, if I could say, that if you don't kind of handle that contingency of listening, and that's happening on the main thread, you could have a case where your app just locks up. But then it is worth understanding that it's this LAN server stuff is actually discrete from the front end. Now, this is the cool thing because since we have this modularity between the front end and the LAN mode library, we may not have to really worry about that contingency. I think that's what's going on here, because I was questioning why I seem to have sort of free access to the front without getting locked out. And it might be because I'm accessing the library, it's doing its thing, whereas this is probably operating on its own separate thread because it's considered a discrete application. So in that case, it's quite good. It's another advantage to kind of separating the LAN logic and your kind of user front as two separate projects within even the same stack, the same solution, if that's what you have to do. So in any case, begin accept, actually, when you call this functionality, if I'm not mistaken, what it does is that it will accept only when pending. Let's actually read it because it'll probably do a better job. So it begins an asynchronous operation to accept an incoming connection attempt. So the connection attempt is incoming. That's when we click the button for the client to send a request, which we'll go through soon. And then once this is a begin accept, so it's already listening. Excuse me. Listening from here, and then it will begin accept. So once the incoming request comes, then it should pass through the begin accept. So we're gonna go through all of this functionality. Let me see how we can do this. Maybe this would be good. It's a good idea to kind of go through the client side of things now. So I'm going to set a break just so I know where I am. LAN mode, I'm going to go to my client namespace. Now I try to keep things fairly kind of similar in terms of the structure of the code, just to make things easier to track and debug. So the client side of things, I have a function in my, so just as I had this kind of simple workflow, bind, listen, and accept, for the client it's just connect so far. So I have a try catch, I have this connect in this NetSocket com client class. Let's inspect this. And then again, I'm defining a port number, which is 1920. This has to match the socket that you're actually trying to establish a network with. So both endpoints, you need to make sure that the port numbers are the same. Excuse me. The IP endpoints may be different because what's actually happening is you're connecting two endpoints which may not be the same. In my case, it's one machine. It's the same machine, which is just right here. But in any case, when you have like two endpoints, you still want them to have the same port number so that the sockets kind of connect with each other. That's how it sort of validates for that socket. Otherwise, you might have various machines connecting with each other in an unintended way. So again, we were looking at the connect functionality, which is right here. IP endpoint, we're constructing this class IP endpoint. So we're calling this get IP address local function, kind of similar to how we did with the server. It's very similar. What we're doing on the server side, on the server component, is very similar to the client component. So the whole way we look at how we write the code, best to keep it as similar as possible to just make debugging an easier experience. Again, getting the host name of the endpoint, in this case, is the same machine. Getting the IP address, and I'm returning the IP address, passing that as an argument to the IP endpoint constructor. And then what I'm doing here, I'm trying to connect. So I'm calling socket.beginConnect. And what this does, and again, this socket object is probably different, if I'm not mistaken. It's a different instantiation. So again, this could be a different machine. This socket is not the same instantiation as, say, the com server socket, which is over here. This is a separate instantiation, two different classes, out of scope with each other. These classes, they don't really know. They're not aware of each other's existence, as it were. So I'm going back to the com client class, and what am I doing? I am calling begin connect, which is accessible through the socket class once it's instantiated, passing an IP endpoint, which you've established here, and a connect callback. And I don't know what that null is. I'm going to see what that is. Object state. Okay, so let's have a look at what this connect callback is. So begins and let me just make sure I'm reading that. So the callback, the async callback delegate. So this callback is actually a function. I'm going to just have a look at something up here. Let me just check out this. Okay, so this callback here, I'm actually passing a function itself as an argument. Excuse me. And this function is connect callback. Let's look at what's happening here. So what this does is if the socket then returns connected, so if in the case that we have established our socket in that the authentication has completed, then this will actually hold for true. This will evaluate for true. And then this string, which I'm not actually using, I just did it for debug purposes. It says connected to the server. Now we're kind of going to the territory of constructing our packet. You can already see here on the client side, I'm on NetSocket.com client, I have that hello world string that actually shows up in the UWP front. This is where it comes from, actually. In this very rudimentary example, this string is being... I've got the string from the client, which sends over to the server via the packet handler, which then the UWP front picks up and then displays, as we saw. There was a bit of issue there because it was only showing this, I think like the LLO world, but at least we get the picture of what's going on. So what you want to do is you want to create a byte buffer. I gave it like a value of 1028, probably overkill, probably over the top. And then you want to call socket begin receive. Let me just check something here. Yeah, so that's still the same socket in the client scope, if I'm not mistaken. So socket.begin receive. Let me just check this. And then you want to pass the parameters or the arguments here. So the buffer is here. You want to pass, I left the offset as 0. The length is just the buffer.length. Socket flags I left as none. Received callback is the function that I think it's a function, isn't it? Let me just double check that. Yeah, so there's another function called received callback. We'll go back to that in a minute, in a hot minute. And null. So let me just put a break so I don't forget about that. Actually, you might as well just check it out now, since it's going in chronological order. So what this does here, I instantiate, I actually assign a value to this buffer length. So it's the length of the socket. So I'm calling socket. I'm actually calling this function endReceive, which passes in the argument a result. And I believe this result pertains to the packet that has been sent. And we're basically, we want the length of that packet. Don't know if I'm using this in any meaningful way, to be honest. But I'm guessing it passes as an argument to this, while I'm handling the packet. Because it's asking for in the argument for this begin receive, I need the buffer.length. But I'm just calling it directly, so I'm not too sure why I'm even using this. So let's just go back up again. I'm just still kind of going through this as I'm reading it. I have a preprocessor directive, hashtag region. Not going to lie, I'm not too sure what that does actually. Preprocessor directives. What is it? Hashtag region. I'm not too sure what that does. I think what preprocessor directives do, they kind of tell the preprocessor to do specific things. Oh. Okay. Sorry about that, guys. It's my leg. Where am I? So preprocessor directive. Let me actually just read the definition there, instead of just kind of gleaning things. So let's just quickly read through this. Although the compiler doesn't have a separate preprocessor, the directives described in this section are processed as if they were one. You use them to help in conditional compilation. Unlike C and C++ directives, you can't use these directives, C# directives, to create macros. A preprocessor directive must be the only instruction on a line. So I want to see if region is there. Okay. So basically defining regions of code that can be collapsed in an outline using the following two preprocessor directives, hashtag region and hashtag end region. So again, if I can remember, I'll leave links in the description if you want to further look into all this. I'm not too knowledgeable on this preprocessor stuff. I need to actually do a little bit more studying into this. In any case, I found that I have this line, preprocessor, hashtag region, initial packet. And again, what I'm doing, I'm kind of creating my packet here. So I have this byte array of 1028. I have I'm basically storing this string in my packet. So hello world is being stored in this packet via encoding, which is a system.text.encoding. It's in the system.text namespace. You can access this encoding class, ASCII, get bytes. So I'm basically converting the string to bytes and storing it in this byte array. And then I'm calling array copy. So I'm copying a source array, destination array, and a length. And again, that's for packet type. Packet length and packet type. Not too sure where that's been defined. Let me just have a quick look. Okay, so they're just global byte arrays, probably used as buffers, both the same dimensions, 1028. And then I'm sending the packet, so this packet here, which has the information that we showed on the UWP front, sending it over the socket we have defined, and then there's hashtag end region. Now I'm going to go to the packet handler class because I want to see where our references are coming from. There's like 6 of them. So on the server side, the main thing to note is that with the packet handler, we are decompiling the packet, it seems. So I have I'm accessing the packet handler class. I wrote a function called decompile packet, and I'm passing the packet in question. Excuse me. Which I may have to come back to this if I don't forget, because this pertains to when the server side, so here I'm on NetSocket com server, when it has received the information over the socket, then what happens is this is eventually invoked, this functionality received on connection callback, and then as we go through the code, we then go onto these 2 lines of code, decompile and handle the packet, which are functions that I wrote, I think. Let me just double check. Yes. So decompile packet, basically passing this the value of this packet buffer, which is basically similar to the string to byte conversion. Now I'm converting the byte to string. So system.text.encoding.ascii.getString of the byte information within this packet, storing that string as in the packet buffer. And then I believe I'm calling the handle function here. And then what the handle function is doing, I've got the packet length, packet type, and I'm basically storing a string, which I don't think I'm doing much with the string actually, because it says packet received length, and then I've got the length, which I'm basically extracting from the packet. I can expose this via debugging if I really need to, I suppose. But the main thing is that now that we have our packet sent to the server component, what I did, if we go back to the UWP front, do you remember that polling clock? So now that we've gone through what's going on in the server client side of things, this polling clock, again, remember, it's doing an inequality check with packet handler.packetBuffer. So packet buffer, again, when we call decompile packet, as I showed you just now, which we actually assign the value of the packet buffer to the string, the converted string from the byte array, which is hello world, basically. We're looking at this member, which is actually public. And yeah, once that has basically updated from an empty string to our hello world, as it were, then this holds for true, this evaluation, and then we update the visual. So we update the visual, the text block.text, with the packet buffer information. So that's a fairly simple rundown into how the LAN component is working via this very rudimentary client-server configuration. Okay, now this is a bit, the thing is, this is a, should I say, I didn't show you guys all of this in the previous LAN stream, because I didn't actually get the component working, if I'm not mistaken. I did look at the video again, just to double check, so make sure I'm not repeating myself, but I skipped to the end of the video, and I don't think I got this far, so this is covering some new ground here. A little bit conscious of the time. Wow, over 40 minutes already. Where does the time go? Alright, so let's have a look at our agenda. We've done a rundown of the LAN implementation. So I'm just thinking, I might wrap it up here, because if we spend a good 40 minutes looking at the full LAN implementation, then I could spend another 40 minutes to an hour in a separate stream or video going over the implementation of the LAN components in the UWP game itself. It's going to be a little bit tedious at first because what I want to do, I was considering actually implementing this as I said earlier, a DLL, my LAN mode library. But then because I'm going to be debugging and updating it, I kind of want to have direct access to the code base. So for the intent and purpose of kind of like simplicity and just general speed, what I have to do, the boring part, is actually, if I go back here, I need to recreate these namespaces and just copy and paste the code. Not going to be too hard. And yeah, and then what I'll do from there is to pass the concept of this functionality that we've ran through, which is a bit of a progression from the last video because I didn't get up to actually passing the information per se, I think. At least I really do hope, because I don't want to repeat myself. And I do hope this comes as to a little bit more of an in-depth look into how the LAN mode is working. But yeah, what I want to do is spend a good amount of time actually looking at the implementation of the LAN mode onto the game, onto a game context. So we might wrap it up soon. No point just going over the namespace. I'm just going to quickly look through this actually. This is a simple tic-tac-toe that I made. So if you tuned into my stream earlier, I was using kind of a, should I say, extended tic-tac-toe game UWP framework, which was actually, I was modifying it to make it a different kind of game, like a kind of a minesweeper match game. But this is just like a simple implementation. I don't really like this. I've actually changed this implementation of checking the rows. But anyway, that's another story for a different session. Again, we're going to keep this video a bit lean. This is on 40 minutes, going on to 50. That's kind of around what I try to target, up to an hour. So guys, thanks for tuning in. Again, we've been running through LAN mode. I took a slightly more, should I say, step-by-step look at how the working implementation is going down using sockets. If you are interested in perhaps, you know, studying / utilizing this code base, please do let me know in the comments. It shows that there's interest, and if there's interest, it means I can perhaps upload the code onto some Bitbucket / GitHub repo for people who might want to learn and just utilize. So let me know about that. Other than that, other resources will likely be in the description. And thanks guys for tuning to this rather late night stream. Well, 4 minutes to midnight, but that's all good. And I bid you all a great day, or even depending on what part of the world you might be watching this in. Thanks guys, have a good day or night. Bye bye. Thank you.